Hello students, we are solving the IB Math AHL past papers and currently we are solving the IB Math AHL November 2022 paper 2 past paper. Today we will be solving the question number 10 of this paper. You'll be getting the links to all the previously solved questions of this paper and of the other papers in form of playlists in my channel NS Online Math Tutoring classes. So, without any further delay, let us start answering question number 10. The maximum mark is 16. The time worked T in hours per week by employees of a large company is normally distributed with a mean of 42 and standard deviation 10.7. So, this is T is a normal distribution variable with the mean as 42 and the variance as 10.7 square. Okay, fine. Subpart A says find the probability that an employee selected at random works more than 40 hours per week. So, subpart A, probability T is more than 40. Okay, fine. So, we have to use the calculator. It is paper 2. I'll be using the TI inspired calculator, CX2. Okay, fine. So it is menu and probability and distribution. You can come to the distribution using the statistics also. And it is normal CDF greater than 40. So the lower bound should be 40. And the upper bound, you can write the upper bound as anything. And mu is 42. So it is 42. And the standard deviation is 10.7. Okay. So this is norm CDF. And what are the values? 40 and then a series of nines. How many nines did I enter? I don't know actually. 1, 2, 3, 4, 5, 6, 7, 8. And then 42 and 10.7. This is equal to 0.574 up to 3 significant figures. So first of all, let me write up to 0.574136. Let me write 574136. Okay, 0.574136, which is almost equal to 0.574 up to 3 significant figures. Okay, subpart B. A group of 4 employees is selected at random. Each employee is asked in turn whether they work more than 40 hours per week. Find the probability that the 4th employee is the only one in the group who works more than 40 hours per week. So the first 3 work less than 40 hours per week. So we will be writing what is. Okay, first of all, let us find the probability of P of T less than 40 hours. So this should be equal to 1 minus P of T greater than 40 hours. Okay, so this is equal to, what is it? Let us find out. This is P greater than 40. So it is 1 minus the answer. Enter. 0.42586. Let me take 0.42586. Okay. 0.425863. 0.425863. Fine. And now it is P of first employee is working for less than 40 hours. This is the first one. And the second one is also working for less than 40 hours. This is the second one. And the third one is also working for less than 40 hours. This is the third one. And the fourth one is working for more than 40 hours. This is the fourth one. Okay. So what will be the answer? For t less than 40, I'll be taking these. So 0.425,863 times, okay, this times this times this, so I can write this as to the power of 3 times this is greater than 40 hours. Okay, so I'll be taking that 0.5741,366. So which should be equal to, okay, let me write it over here, which should be equal to, this is the whole thing. So raised to the power of 3 times this one. I can just select this and Control C, and let me see if it works. Control V. Yes, it is working. So enter. It is 0.044343. 0.044343. Okay, 0.044330 and something 09, most probably 309, yeah, 0907. So up to 3 significant figures, it will be 0.0443. 0.0443. Up to 3 significant figures. Clear? Okay, so we are done with subpart B. Now coming to subpart C. A large group of employees work for more than 40 hours per week. It is containing two subparts. So first subpart is saying an employee is selected at random from this group, means the group which is containing, which is working for more than 40 hours per week. So this is a condition. Okay. Hence it has to be a conditional probability. So find the probability that this employee, one employee is selected at random from this group. So find the probability that this employee works less than 55 hours per week. Definitely the employee is working more than 40 hours, but at the same time, he or she is working less than 55 hours per week. Okay. So what will be the probability? It will be P of T less than 55 given that T is more than 40. Okay. So this is P of T more than 40 but less than 55 over P of T more than 40. And P of T more than 40, we have found this. Okay. So I can write this as 0.574 1366. And this one is 40 to 55. Okay. And the mean was 42 and the standard deviation is 10.7. Okay. So we go to menu and this is statistics. This time I'm choosing the statistics and this is the distribution. And I come to normal CDF 40 to 55. So lower bound is 40, upper bound is 55, mean is 42, and the standard deviation is 10.7. Okay, it is 0.4619, 0.461944, let me just check once more. 0.4619446. Okay, and the next one is 7. Fine. So this should be equal to what? Approximately equal to. Okay, so the answer, the numerator is the answer, and the denominator will be, it was this 0. This one. So let me just copy and paste. Yeah. And then I press enter. 0.845, 0.8459 I am taking. 0.84, sorry, not 84, rather 0.80459. 0.80459. 0.80459. Okay. And again, this is, I can write this as 0.805. I can write this as 0.805 up to 3 significant figures. Okay, fine. And we have answered the first subpart. Coming to the second subpart. Okay, it is the second subpart. 10 employees are selected at random from this large group who are working more than 40 hours per week, and find the probability that exactly 5 of them work less than 55 hours per week. So that means they are taking this section which is working more than 40 hours per week but less than 55 hours per week. So they are taking this section. Okay, so that means I can say, I'm naming it as W because it refers to the work done. So I could have taken H also. So this is a binomial distribution variable. I could have taken the employees, anything. I've taken W. So it is a binomial distribution variable. It refers to the number of employees, in fact, who are working more than 45 hours but less than 55 hours, and the maximum number of that group is 10. So number of trials is 10. And the probability of success is this one. Okay. So probability of success is 0.80459. Okay. So we need to get the probability of P of W equal to exactly 5 of them. Equal to 5. Clear? So we will be taking, I can take either binom CDF or you can take binom PDF. Let me take binomial CDF has come. So let me take the binomial CDF. The number of trials is 10 and this is the probability of success. So number of trials is 10. Probability of success is, you can read from this point over here, 0.80459, and the lower bound is 5 and the upper bound is also 5. So in case you have equal to, you can use the binomial PDF also. In case if you use the binomial CDF, you have to write the lower bound and the upper bound as the same number. Okay, but doesn't matter whether you use the binomial CDF or the binomial PDF, you will ultimately be getting the same answer. So it is binom CDF 10 comma, let me just write it. It is binom CDF 10 comma 0.80459 comma 5 comma 5. I'm giving this as the up to 3 significant figures because this is the final answer. So I'll be giving up to 3 significant figures, 0.0242. Okay, 0.0242. So 0.0242 up to 3 significant figures. Okay, it is known that probability of T greater than or equal to A but is less than or equal to B is 0.904, and probability of T greater than B is equal to 2 times probability of T less than A, where A and B are number of hours worked per week. An employee who works fewer than A hours per week is considered to be a part-time employee. Subpart D says for the maximum time in hours per week that an employee can work, find the maximum time in hours per week that an employee can work and still be considered as part-time employee. Okay, so this is the normal distribution curve, and the mean is 42, so this is 42, and this may be A, this may be B. Probability of T greater than B is this part, and probability of T less than A is this part. I have taken the probability of, let me just start answering. Let probability of T less than A equal to P. Then probability of T greater than B will be equal to 2P, because 2 times this is 2P. So this is P and this is 2P. And you know the sum total of all the probabilities should be equal to 1. So we are having therefore P plus, it is plus, so it is okay, since I have written P, it is again I am writing the same thing in fact. I just didn't want to delete. So therefore the middle part is 0.904. So P plus 0.904 plus 2P should be equal to 1. Clear? Or 3P should be equal to 1 minus 0.904. Okay? Or P is equal to 1 minus 0.904 divided by 3. Okay? So I'll be using the calculator. 1 minus 0.904. Oh my goodness. 1 minus 0.904 over 3. 0.032. Okay. So therefore, P is equal to 0.032, right? 032. That means, therefore, probability of T less than A is equal to 0.032. Okay. And we have to get the value of A. So what do? We will be using the inverse normal. Okay. Therefore, A is equal to inverse normal. I have to use the inverse normal. So this is this. And the probability is 0.032. Okay. So 0.032. And the mean is 42. And the standard deviation is 10.7. Okay. So inverse normal 0.032. Okay, let me write it. So inverse normal 0.032, 42 and 10.7 is equal to 22.2 I'm taking. Okay. 22.2 hours per week up to 3 significant figures. Okay, so therefore, or so, the maximum time in hours per week uh, that an employee can work and can be considered as a part-time employee is 22.2 hours up to three significant figures. Okay, we have found the value of A as 22.2 up to three significant figures. So this is the maximum time in hours per week that an employee can work and still be considered as a part-time employee. Okay, so this brings us to the end of this question. We have answered this question completely. Thank you for staying with me till the end. I am Nilanjana Sanyal. I am an online IB Math ESL and HL level tutor. I tutor students from both within India and outside India, and I tutor in one-to-one form and in small group online session form also. So, in case you are liking my explanations, please to give this video a like and please to share this video with your friends so that even they can get benefited by watching this video. And in case you have not subscribed to my channel till now, please do subscribe to my channel. It will be motivating me to make more math videos for you because then I'll be knowing that I'm being able to help you. And in case you have any doubts, any queries, please feel free to write to me in the comment section. I'll be trying to help you as much as possible. Okay? So we meet again very soon in our next session where we'll be solving question number 11 of the same paper. Till then, bye.